A rare scientific event is about to unfold. The interstellar visitor known as 3I Atlas has begun forming a striking ion tail as it approaches its closest point to the Sun. And by pure coincidence, two spacecraft, NASA's Europa Clipper and ESA's Hera mission, will be moving straight through the region, trailing behind it in just a few days. This wasn't planned, but it may open the door to the first ever direct readings from the tail of an interstellar comet. In this video, we'll explore how this opportunity came about, why it's scientifically important, and what might happen next. Let's dive in. The object known as 3I Atlas is the third confirmed interstellar visitor, following Oumuamua and 2I Borisov. It's been gradually brightening as it nears perihelion, its closest point to the Sun, on October 29th. As solar radiation increases, Atlas is venting gas and dust, creating a long, curved tail of ions and water vapor driven outward by the solar wind. At the same time, two missions are traveling through the inner solar system. Hera is en route to the Didymos-Dimorphos binary asteroid system to study the aftermath of NASA's DART impact test. Meanwhile, Europa Clipper is heading toward Jupiter's moon, Europa, a world believed to hide an ocean beneath its icy crust. By sheer coincidence, their flight paths cross the extended space influenced by 3I Atlas's tail. For Hera, the potential encounter window is October 25th to November 1st. For Europa Clipper, it's October 30th through November 6th. Researchers modeled the tail's shape and trajectory using a simulation tool called Tail Catcher, which factors in solar wind direction and speed to predict how ionized material flows outward. According to those models, both spacecraft are set to pass about 8 million kilometers from the tail's central axis, far from the comet's core, but well within the diffuse ion cloud. Hera doesn't carry instruments for plasma or magnetic field analysis, so its contribution would mainly be geometric data, helping refine the alignment of the encounter. Europa Clipper, however, is equipped with a magnetometer and plasma sensors, instruments capable of detecting changes in charged particles and magnetic fields, the exact kind of effects expected near a comet tail. This event will be brief, and since solar wind conditions can fluctuate, the tail may shift or twist in real time. Even so, this alignment presents a remarkably rare chance to study an interstellar object directly, using spacecraft that are already out there. Interstellar objects like 3I Atlas are windows into the chemistry of other star systems. Their compositions and behavior can reveal what environments were like in their original birthplaces. Up until now, every study of such objects has been remote, carried out with ground and space-based telescopes. No spacecraft has ever taken direct, in-situ measurements. If Europa Clipper manages to record data from the tail of 3I Atlas, it would represent the first direct sampling of material from beyond our solar system. Even a small amount of data could help scientists compare its makeup to native solar system comets. Researchers are primarily focused on three goals: ion and plasma analysis, measuring the density, energy, and distribution of charged particles in the tail; magnetic field structure, determining how the comet interacts with the solar wind and how magnetic lines are distorted; comparative behavior, seeing whether interstellar comets behave differently from local ones under similar solar conditions. This encounter also provides a valuable test for theoretical models. The tail catcher simulation predicts how solar wind shapes the tail's geometry, but no direct measurements from an interstellar comet have ever been taken to confirm those predictions. Even a partial or low-resolution dataset would help refine those models and improve future forecasts for similar encounters. Of course, uncertainties remain. Both spacecraft will pass far from the densest part of the tail, so the ion flow could be weak. The tail itself might shift unpredictably with solar wind changes. And since neither mission was designed for this event, there's little time to adjust instruments or mission plans. Still, even limited results, or a null detection, would provide meaningful scientific constraints. If Europa Clipper successfully gathers data during this brief alignment, it would mark a milestone for interstellar research. For the first time, humanity could obtain direct measurements from the outer environment of an object that came from beyond the sun's reach. Such readings could help scientists better understand how interstellar comets interact with stellar winds, trace their origins, and refine models of planetary system formation. This moment also highlights the importance of flexibility in mission design. Neither Hera nor Europa Clipper was built with interstellar studies in mind, yet with slight adjustments, Europa Clipper could return data of real scientific value. It's a reminder that sometimes unexpected alignments can lead to major discoveries, and that being adaptable can turn chance into opportunity. The experience from this encounter could also guide future missions. The European Space Agency's Comet Interceptor, for example, is being developed to chase pristine comets, possibly even interstellar ones. Data from Europa Clipper's flyby could inform everything from instrument calibration to mission planning for those future probes. But time is short. Hera's role will likely remain limited to position tracking, while Europa Clipper's instruments need to be configured in advance to capture useful readings during the narrow encounter window. Afterward, scientists will compare the observations with model predictions to fine-tune their understanding of tail dynamics and solar wind interactions. Even if the spacecraft detect nothing, that result still matters. It would define sensitivity limits for future missions and set a baseline for what to expect when we meet the next interstellar visitor. This is a rare and unplanned cosmic coincidence, a fleeting chance to study an interstellar object up close. If Europa Clipper succeeds, it could capture the first direct measurements ever taken from the tail of 3I Atlas. Whatever the results, they'll shape how future encounters with interstellar travelers are prepared and pursued. Thanks for watching, and stay tuned as humanity reaches out, once again, beyond the solar system.